Welcome to another episode of the Distributed Data Show, brought to you by DataStax Academy, where we bring you the latest news and interview technical experts to help you succeed at building large-scale distributed systems.
Welcome to another episode of Distributed Data Show. My name is DuyHai Doan, and today I'm with Tillman.
Hello, everyone.
So, Luke, today we are talking about pre-aggregation in an eventually consistent world.
And that sounds like a whole bunch of weird buzzwords all kind of mixed together into a sentence. I'm pretty sure you just made that up.
Yeah, don't worry. I will explain everything.
Okay, so you said we're going to talk about pre-aggregation in an eventually consistent world. So maybe start by explaining to us, what do we mean when we talk about eventual consistency?
So yes, eventual consistency is distributed design, architecture design. It is closely related to a masterless architecture, right? In a masterless architecture, you have different copies of your data, like because in distributed system, to avoid data loss and to be highly available, we need to duplicate data. This is the basic idea of every distributed system.
And we do this even with relational databases when we try to make them highly available, right? We set up these master-slave kind of architectures.
Yeah, there's nothing new there.
Yeah.
The only difference is in a masterless architecture, all your replica are strictly equal. Okay. I mean, there is no primary replica, no master replica. Everything is strictly equal. And so the gain from this is you don't have any single point of failure. You can write to any replica. It doesn't matter. But the drawback is now, whenever you have inconsistency in your data, because you don't have a central point to decide which version of your data is correct, you need to somehow propose an algorithm to resolve the conflict.
Okay, so you're saying maybe replicas might disagree on what the current copy of the data is, because there's no master that is the one that's sort of in charge of deciding what the latest copy is, and so you have to figure out. So how do we do that? Like, how do we do that in Cassandra? Like, what's the way?
So the conflict resolution is done always at read time.
Okay.
And in Cassandra, we implement what we call the last write win algorithm. So the idea is every time you write a piece of data in Cassandra, the coordinator of Cassandra assign a timestamp to this piece of data, which is a metadata. The timestamp is the metadata. And we use this metadata at read time, and Cassandra will compare a timestamp on each replica, and we'll take the latest, the last write win, right?
Makes sense.
Really simple idea.
So what is the sort of performance implication of putting off that, like doing the conflict resolution that way? Like, what does that mean as far as performance goes? So
it means that basically it is very fast to write your data, because when you write data, you don't care about conflict resolution. You just dump data on this, blah, blah, blah. And when you are reading data, it's another story, right? You need to compare timestamp. And of course, historically, Cassandra was much faster for writing than for reading. But since then, we introduced a bunch of data structure like Bloom filter, like primary key indexes, so that it makes the read faster. But by design, writing will always be a little bit faster than reading.
Right. So I just want to point out that when I write data to Cassandra, the blah, blah, blah sound effect makes total sense, because most of the time I'm writing cat video data or something equally as unimportant. But most of you listening out there probably write something more important than cat video data. But when you're the guy that did killer video for 3 years, this is what you're stuck with. But okay, so we kind of understand eventual consistency. We got it. What about aggregation though? So we're going to talk about pre-aggregation and how we do pre-aggregation. What does aggregation mean? So give us an example, maybe.
A very simple definition by example. Think about group by, right?
Group by, okay. So like from SQL.
Select some columns from some table, group by whatever, group by year, group by date. And by the way, talking about group by, I should mention that since Cassandra 3.9, we have the group by feature in Cassandra now. You
Okay.
can group by on partition key and clustering column, of course, but not on any arbitrary column. And so the idea is, when you are using group by with Cassandra, the new group by introduced from Cassandra 3.9, it's not very fast. Why? Because you need to fetch a lot of data. Because in fact, the grouping is done on the flight when you're reading data. So the more you have data to group by, the longer it takes. There is no magic there, right? So the idea of pre-aggregation is, instead of doing the grouping or whatever, the summing at read time, why don't we do it at write time?
So you're saying that the whole idea of pre-aggregation is how we're basically trying to solve the problem. How do we make it faster? Because right now it's slow because we do this aggregation every time. So right now we don't have pre-aggregation implemented in DSE. This is or in open source Cassandra. This isn't a feature, but I know you've had some sort of pie in the sky kind of ideas, and I think this is kind of what we wanted to discuss. Was how would we go about implementing pre-aggregation in DSE or in Cassandra?
So my original idea was to make Cassandra also a reasonable fit for analytics scenario.
Okay.
That was the original requirement. In fact,
Is this because aggregation is so common, right?
Yeah,
on the
it's so
OLAP
useful
side.
right now.
Yep.
And so I was thinking, right, we have already the secondary interface, the secondary index interface that hook up on the write path of Cassandra.
Okay.
Why don't we use it to duplicate data on another format, which is really, really a good fit for analytics? For example, where I was thinking about Apache Parque data format, or even Lucene doc values, right? The new feature of Lucene.
What's for anybody out there who's listening who's not familiar, what's Apache Parquet? Like, what is the implication of storing data in a Parquet format?
So Parquet format is a columnar format, and the idea is to store in. So Cassandra storage engine is row based. It means that we are accessing rows anytime, every time, and the columns are stored together for each row. And with a columnar data format like Parquet, in fact, it is all the rows for each all the columns for each row are stored together.
Right.
And it is best suited for the scenario where you want to say select some columns where you put a predicate on those columns. Because with Parquet format, you have a lots of indexing structure to skip reading data.
Yep.
And this is really fast. It has been designed for this.
So you don't have to read like in a row format, you don't have to read a whole row and skip a whole bunch of data that you don't care about. In Parquet, the column values that you care about are all stored together. Okay. So you're saying we use this secondary index interface that we already have to store that data in a second format. What kind of stuff would we store? Can you give us an example of what this might?
So let's take the very classic example of time series. You have date, which is every piece of data, it has a timestamp, and then you store some values, some metadata with your sensor. So what we want to store, for example, in this format, the new data format is, for example, the primary key.
Okay.
Replicate the primary key of the base row in Cassandra. We can pick some column we want to keep in this new data format. We want to collect some metrics. We can also, because we have flexibility at write time, we can also define pre-filtering. For example, I can say, I want to keep only time series value where the temperature is greater than 20 degrees Celsius or whatever.
So you're getting an example
pre-filtering.
Like sensor data, if I was storing a time series sensor data where they stored the temperature, I might be able to filter on
exactly. So you will have one data structure to store all the temperature between some threshold, another data structure on another index to store another threshold for temperature and so on. we can think about pre-sorting and pre-grouping, because it is very common for people that they want to group their time series by week or by months, and then compute the sum, the average, right? So we can also think about pre-computing all those values, sum, mean, max, average, median, and so on.
Yep. So you're basically saying like that using, and this is kind of what I think we did an episode on secondary indexes where they use this interface, for example, SASE, to flush the index at the same time that the SS table is written. So you're saying that we would do this sort of aggregation at that point where we flush the data, so we could kind of
some kind of idea. Yes.
Yeah. Okay. Very cool. So this sounds really easy. It sounds like it sounds like you've already figured it all out. Why haven't we actually gone ahead and done this yet?
So that was my big surprise when I was thinking about this idea. Whoa, if I can think about this, why didn't we implement this?
I mean, you're a little bit of a genius.
No, I'm not the smartest. No. So in fact, there is a very good reason, because remember what I just talked about at the beginning of this data show. We are in an eventually consistent world.
Okay.
Which means that we resolve conflicts at read time.
Okay.
Now let's take an example, the sum. Suppose you are pre-computing the sum.
Okay.
So every time you have a new value coming in, you just increment the counter, right? It's a counter, the sum. Now let's say that you have 3 replica. One of the replica has missed some values. It means that now the sum from this replica is different from the other replica.
Okay.
And the worst thing is, because you don't keep all values, you are just keeping the sum only, the aggregated value. You cannot know which sum is the correct one.
You don't have the history. Okay. Yeah.
Exactly. You lose all the history because and the worst example is min and max.
Okay.
Because with min and max, if you miss a single write out of 1 million writes, and by chance this write is a min, your min is completely wrong.
Right.
See the idea? And in fact, the only way to be accurate and to avoid this kind of inconsistency is that you have to keep all the values.
Yep.
All the values in your data structure. But it means you need to store timestamp, you need to store tombstone, you need to re-implement the last right-win logic again at this layer. So you duplicate again the logic of conflict resolution.
Yep, makes total sense. So is that sort of the only kind of like problems that we're facing in an eventually consistent world? Like it's basically we have to go and re-implement sort of the last right wins or whatever it is, or what are some of the other like implications of, what are some other systems, for example, that would be impacted by by having sort of pre-aggregated data?
So the other implication is performance, of course, because when you are writing right now, you are writing the base data in Cassandra. You need to also to wait until the data is written in your whatever data structure for analytics. And this whatever data structure may not have the same performance characteristic as the SS table, which is a log structure mastery.
Right. So we're talking about write amplification almost here. Like, so you're writing to multiple, potentially multiple.
Of write taking longer.
Right.
Because when you are writing to those data structure, you may also update some of the internal index of those data structure. Right?
Okay. Yep. So
you may build some indices, and it takes time.
Yep. So that's not, the write isn't as cheap as it was,
No.
which has been for a long time one of the biggest selling points of Cassandra and DSE is that, wow, you can write data really, really fast and ingest
Because
data.
we are just appending data.
Yeah. Yep.
It's no way faster than appending data on disk.
Sure.
Right?
Yep. So this sounds to me like the sort of what you proposed with the secondary indexes and using that interface, like kind of sounds to me almost like making basically the whole storage engine itself pluggable. And I know there's been some debate debate, in the past about, should we, shouldn't we? So maybe give us like a recap. What are the pros and cons of maybe just making the storage engine itself pluggable, and what's kind of going on out there in that area, that sort of.
So yeah, it's a good question. Recently, on the mailing list of Apache Cassandra, there are some people that are telling that they are implementing RocksDB as an alternative storage engine. So the idea is, okay, it's good. The only thing to be careful about is it will impact a lot of Cassandra base code, right?
Okay.
And also the architecture, because right now, when you think about, for example, the secondary interface, right? We use because we assume that we are dealing with SS table and all of its metadata. Now, if you know that it is not necessarily SS table, but some data structure from RocksDB, it's a whole new story.
Right.
The same for the read pass. Right, the read pass right now we are using Bloom filter, we are using partition index summary, and so on. With RocksDB or another storage engine, the index structure may be different.
So it almost becomes like you can't just do the storage, and then you kind of have to do the whole read path all the way up in this case.
We need to re-engineer our read path to be more like interface, make them like interface and very abstract, so that we can plug in any implementation we wish, and not to leak internal details up to the read path. That's the main challenge. And I'm not even mentioning the problem we have with SQL, because SQL semantics, I'm talking about semantics here, right? Is the semantics of SQL are closely related to our current storage engine, right? For example, when we talk about support for counters, support for collections, partition key, clustering column, RocksDB is a key value data store, right? So how do you support the idea of clustering column?
Okay.
How do you support the idea of collections, of
Right.
counters? I'm a little bit concerned when we have different storage engine and we say, okay, with this storage engine, we cannot have a collection in SQL. You cannot use collection, you cannot use counter, you cannot use clustering column. I'm really concerned, because now we are breaking our contract to external client.
Right.
You change your storage engine, you break your SQL semantics. Not good.
Kind of reminds me of when people implement an interface or something in Java or C# and they throw not implemented exceptions for the parts that
exactly.
they're not, and it's like a runtime error, which is the worst experience ever.
So you end up having like a matrix of like, okay, with this storage engine you can use this feature, with this one feature, like crazy matrix of what you can use with SQL or not.
And you didn't even talk about compaction. Like, so for compaction, as an example, is something that the current storage engine uses. That when I create a SQL table, I can set table options that say what compaction strategy you use. So, is that even a thing?
So the compaction, to be honest, the compaction is very low level. I mean, it's at the storage engine level. So we can imagine that RocksDB or whatever storage engine manages its own compaction. But on the, again, SQL semantics, when you say create table, with compaction strategy, today you can use a size year level or time windows compaction, right?
Yep.
Tomorrow, if you know that you are using RocksDB, you may not be allowed to declare compaction strategy size year.
Yeah, that made no sense.
No sense. So it means that you are introducing like a kind of compatibility matrix. If you are using RocksDB, you can use those compaction strategy, and then blah 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 blah.
So let me ask you an opinion question, kind of to finish up. Like, do you think we'll see like a pre-aggregation implementation at some point, or pluggable storage engines, or something like that? Do you think we'll see something like that in Cassandra?
Yeah.
DSE?
Technically, it's challenging. I will not say that it's not doable. It's feasible. It's very challenging, but I think that because aggregation is so common and so useful today, yeah, we may see some kind of implementation of this nature in the future. Maybe not using exactly the secondary index interface, maybe using other mechanism, maybe a hard fork of the write pass. But yeah, we may see something like this in future.
Very cool. Okay, well, I hope that everyone out there listening or watching has enjoyed our discussion of pre-aggregation in an eventually consistent world. Of course, we want to say thank you to DuyHai for all of the knowledge. And we will see you next time on the next episode of the Distributed Data Show.
Thank you for joining us again for the Distributed Data Show. We love your feedback, so go to the Distributed Data Show page on DataStax Academy and tell us what you think. You can also find us on the DataStax Academy YouTube channel or find our podcast on iTunes, Google Play, or wherever you get great podcasts. While you're there, make sure and subscribe so you don't miss a single episode.